Today we're going to look at section 8.2, which is exponent properties with quotients. Now yesterday we talked about exponent properties with products, so today's really going to be a lot of the opposite of what we were doing yesterday, because yesterday when we multiplied the same base, we added the exponents. Well, today we're going to learn that the quotient of powers property says that when we divide the same base, we subtract the exponents. So that's our rule. If we're dividing the same base and they both have exponents, then we subtract the exponents to get the solution. So our first example would be 12 to the 9th power divided by 12 to the 7th power. I have the same base, 12, and we're dividing, so I'm going to subtract those two exponents and we're going to simplify it to 12 to the 2nd. Now I could also say that that's 144, but for today we're just simplifying what's going on. Now let's look at another example, number 2. What if we have a negative number in the parentheses, negative 2 to the 15th power divided by negative 2 to the 10th power. I've got the same base, so I subtract my exponents and I get negative 2 to the 5th power. Now it is absolutely imperative that if a negative is inside the parentheses, it stays inside the parentheses. If the exponent is outside the parentheses, it stays outside the parentheses, because that does affect the answer of your simplification, or when you multiply it out, it affects the answer. The next property that we have when we're dealing with quotients is the power of a quotient property. So when we've got a power of a quotient, it's going to look something like this: x over y to the 5th power. That is the power of a quotient, because we've got dividing going on inside the parentheses. And in the power of a quotient, you apply the power to the numerator and I'm capitalizing that, and the denominator, then simplify. So I'm going to apply the exponent, or the power, to both the numerator and the denominator, so that's going to be x to the 5th over y to the 5th. Now those aren't the same bases, so there's nothing else that I can do. This is as simple as it will go. Here are two more examples that deal with the power of a quotient property. If I have 3/5 squared, then I'm going to square the 3 and then square the 5. And depending on what the instructions ask you for, whether it's to simplify or to solve it, then you could have 9 over 25. But either of those answers would be right. Now let's look at the next example, 6m cubed over 2x squared. So the first thing I have to do is use the power of a power property from yesterday and figure out, apply the exponent squared to everything inside the parentheses. So that means 6 squared m to the 6th, because remember, power of a power, I multiply those two exponents, over 2 squared x squared. It is very, very important that you remember to apply the exponent to everything, even the constants that are inside the parentheses. And then I can keep going. That would be 36m to the 6th over 4x squared. I just did some more simplification. And now I can't do anything with the m to the 6th or the x squared because they're not the same base, but I can simplify the 36 and the 4. And if I cancel those out, this becomes 9, and that just becomes 1. So my final simplification is 9m to the 6th over x squared. We're using the properties from multiplication in order to solve division problems as well. Let's look at two more examples on the same property, power of a quotient property. Let's say that I have negative 5 over r raised to the 3rd power. So I'm going to do exactly the same thing. I'm going to keep the negative, and then I have 5 to the 3rd over r to the third. And that's all I can do because I don't have any same basis. If I wanted to, I could do 5 to the third as 125, but I could leave it as this, simplified this way as well. So again, it depends on the instructions. Number 4, I have x to the 5th over y raised to the 3rd power times 1 over 4x to the 5th. So we're going to take it one step at a time. First, I have to apply this 3rd power to everything inside the parentheses. So that's going to take me to x to the 15th over y to the 3rd times 1 over 4x to the 5th. So I'm just going to keep going. Multiply x to the 15th times 1 is x to the 15th over 4x to the 5th y to the 3rd, 4x to the 5th y to the 3rd. Now I can't do anything with my 4, and I can't do anything with my y cubed, but I can simplify the x's here, okay? So x to the 15th divided by x to the 5th is x to the 10th, because I subtract those two exponents. So basically this one goes away, and this becomes a 10. So my final answer is x to the 10th over 4y to the 3rd. Once I cancel an x or a variable from the numerator or the denominator, I can just get rid of it, and I don't need to put anything in its place. Okay? Here are your 3 practice problems for tonight. The first one is 6 to the 8th divided by 6 to the 5th power. The second one is 3 squared times 3 to the 6th divided by 3 to the 3rd power. And number 3 is a squared over b all raised to the 4th power times 1 over 3a to the 7th power. Take a picture of those when you're finished and submit them through Edmodo so I can see how you did.